Hey, hello everyone and welcome in a new video. In this video I'd like to explain you how services work behind the hood. We will discover how services is just like iptables rules. This is really interesting to know that, for example, to troubleshoot, but usually to well understand how Kubernetes works. So don't hesitate to subscribe to the channel to not miss the next video, comment and like this video to support me. So let's go. Just a little reminder, we have when we have a Kubernetes cluster, we already have seen that we have master. On master we have a kube API server. This is our main entry point from the external traffic or internal traffic inside the cluster. We have the etcd, so this is a database, a controller, some controller manager. We saw that we have the cloud controller manager to handle the load balancer services, and the scheduler, for example, to set the node name for each pod. On worker, we have the kubelet, and the kubelet just need to be in sync with the kube API server and what we have into the etcd, and the kubelet take and give some actions to the CRI for container runtime interface to create some containers, of course, and behind that at the operating system level, this is just some settings about cgroups and namespaces. And especially for services, we have another tool named kube-proxy, and the kube-proxy is just a tool like kubelet, for example, that take and give some actions to iptables, to set some rules on iptables, and iptables do some stuff on services. And this is the purpose of this video, to just discover that. Some words before, our service is created inside the Kubernetes, and so usually sometimes there are some exceptions, like for example, if you use eBPF with Cilium, for example, this is totally different like that. But the first thing, you create a deployment and you set some labels for this deployment, and of course you send a request to the API server with the selector to set a new to create a new service. And after that, the API server just match endpoints dynamically, of course, to discover each IP endpoint that can serve your traffic. And after that, the API server gives all IPs and port to kube-proxy. So we are here. So the API server provides to kube-proxy each API endpoint, even if it's not on the same worker. The purpose is to cover the entire cluster. And after that, all kube-proxy on all workers or masters handles iptables and add some rules inside iptables. Sorry. And then just iptables do some dnat rules and send the traffic across all the nodes. So for example, if a request is just received on one of master, and the master has some rule about to redirect the traffic on a pod on this worker on a specific port, and the iptables just rewrite the package and set it to the other worker, and of course to the good pod. Yes, and just take care about this part. We have 3 modes to set, or 4 modes to use kube-proxy or to set or to configure services. The first one, and this is a legacy mode, this is the user space mode. This is an old thing. No cluster use that right now, but this is an old method to set services. Now, usually we use iptables, so this is our case with our little cluster, and yes, this is a drawback about to use iptables inside kube-proxy or with kube-proxy. So this is what we named iptables mode for kube-proxy. Why this is not really good? Because when you have multiple or many services inside and many pods inside your Kubernetes cluster, you have many rules, of course. We will see how for just one service we can have multiple rules. But you have many rules, and many rules means that you have a heavy workload for your CPU and you increase the latency, because iptables can just handle each rule sequentially. So this is just an incremental stuff, and that takes a lot of time and a lot of CPU cycle. So this is not so bad if you have just 100 services, for example, but if you have 1000 services, this is really bad. You increase a lot your latency, and you just lost your CPU cycle. And to avoid that, you can set the kube-proxy to use IPVS. We will see that later. And this is really lighter than iptables mode, because IPVS doesn't work like iptables. So this is not an incremental stuff, and this is not like we have many rules, but IPVS use only one tables and just estimate and handle each package, at a time, but for the entire rules. So this is really easy to know that it's better than iptables, of course, for your CPU cycle or your latency. And IPVS provide other because we know now that services in Kubernetes can as like a load balancer, and by default with iptables you only have one load balancer algorithm, just the round-robin load balancer. But with IPVS we will see that we can use multiple kind of load balancer. And the latest and the new way to simplify or to improve performance inside the Kubernetes network is to remove just the kube-proxy. This is like, for example, what Cilium makes with IPVS, and this is really performant, of course. So let's go. This is for the next video that, and we can go inside our cluster and just check what is the iptables part for services. So let's go. I can just open two terminals like here, and now what I want to do, I can create with a kubectl create, and what I want to create a deployment named Nginx, and an image, of course, Nginx, and maybe we want to have multiple replicas. Take care, because here we set directly replicas inside the kubectl create deploy. For example, here we can set to 10 directly without put kubectl scale deployment or deploy nginx -- replica 10. we can do it directly. So now we have 10 replicas. So this is in container currency status, but at the end we will have all what we need. And after that, we can create, like in the previous video, what we want to create. We want to create a service named Nginx, and by default that set the selector to Nginx with app Nginx, app for the key, Nginx for the value. We want to create a service, not port service, we can add it here. And after that, --TCP, the port of our service and the target port to push the traffic to our Nginx pod, of course. So kubectl get svc to check that, and of course if I use the curl here, it seems that it works, I think. Yes, it's good. Perfect. So now what I can do, I can go directly as root, because we will use many times iptables, so we need to use a sudo, but by default I can use root. I can kubectl get svc just here, and now we can use iptables -t, and we want to query the table, the NAT table, of course, because we use dnat like we said, and -L, and with that we just query the chain, the pre-routing chain. So the pre-routing chain is just our iptables handle package, and after that what we have, we can see that we have only one rule named kube services. So this is the name of the chain, not exactly the name of the rule, but the name of the chain. So we can do the same things and replace the pre-routing chain to enter into the kube services chain. And if we do that, we have multiple lines into it. And what do we have? If we check that here, the first things on the left, we have some kube svc, so for service, and an ID after that. We have the protocol, the source, so for each package provided by, for example, anywhere, and the destination for each package is this one. We apply these rules. Okay, and after that we have here a separator dedicated to a comment in iptables, and in this comment what we have the name of the namespace slash the name of the service and some element. For example, here we have the service port and the target port, you can see here, and we have the kind of service. In our case we use the node port, but node port is just another rule here, and a cluster IP rule. So this is the like we make the addition about all stuff. And after that, what we have the destination port with the protocol, and the destination port is http-alt. http-alt in iptables is just to say 8080. So this is not the HTTP. HTTP is 80, a simple 80, or HTTPS is 443, but HTTP alt is for 8080. Okay, and of course here we have some IP, and if we check, this is each IP for each service. If I use kubectl get service and -A, I can see that I have multiple services, and I can find this service here. Okay, so I can use again here the name of the service again, and I can remove the chain and replace the chain by this new chain. And what we have again multiple lines, and we have kube mark mask for masquerade and mark for marker. And of course, this is the first rule, and what kube-proxy set, because this is kube-proxy that it push inside the iptables this rule and set it into it, and he said with the protocol, of course. And if the package if the package doesn't come from the CIDR, the pod CIDR, this rule is applied. And the destination and the other filter is the IP, the destination IP. Of course, this is a service IP. So if a package come from not a pod and want to go to this IP, this is all these rules are applied. Okay, we have also our previous comment, the same thing, but we have here 10 lines. Of course, we have 10 pods, so it's okay. And what we have for each line, we have a new name here about a new chain. All, so this is the protocol, and anywhere where to come and to go anywhere to. We have another comment here, and in this comment we have the service, but the service seems to be the source, so you can see here, and to go to the pod CIDR and pod IP. If I use kubectl get pod -o wide like here, of course, I can see, for example, here the .10 IP. The .10 IP, of course, is here, and we are on the pod. So the target, so this is the target port. So this is the port 80. And after that, here is just a comment. But after that, we have some statistic and mod random probability. What does it mean, this kind of stuff? This is really simple, because this is how to set a load balancer inside iptables when you want to make a round robin. But you can just say, why do we have a different probability for each line? Because if I just apply that like that, that means that the first IP here doesn't receive the same package number than this one, for example. Just no, it doesn't work like this. It's for example, here you take the first line, and for the first line that means that each element can at this level of these rules. Remember that each rule is applied one line per one line and in an incremental mode. That means for the first line 10%. These rules can be applied to 10%. After that, we need to compute the second rule not on 10 lines but on 9 lines, because the first line is already applied. So this is not 10% that we will apply, but only 11, a little bit more, 11%. And again, for the third line, this is the same thing, because we have just 2 lines, so we remove 2 lines, and now we have only 8 lines, and that means that we have 12%, etc., etc. And if you check, before the end, if you take, for example, this one, we have only 2, the rest is 2 lines, of course, and so to load balance between 2 lines, what we need to do, we need to apply a probability set to 50%, and at the end, of course, no need to apply probability into it. Cool. Okay, so this is how it works, and you can, I don't remember, but you can apply again here some element, and this is the last rule apply here, and you can see when a package need to go to this IP, so this is the IP, the final IP of the port, it can go to it directly and apply this dnat rule, and you can see here the destination. So this is a NAT, so this is like we rewrite a package and send it to this new destination. And remember here we have just this rule at the beginning to say, oh, this is just how we want to apply that to all traffic never comes from the pod network. And we will see later, because for the pod network, this is another mechanism that we allow us to handle this kind of stuff. And for the other mechanism, we never use the dnat or the NAT. We will see that later. This is really interesting also. But here, this is for the services and for how Kubernetes and the kube-proxy set iptables to handle the external traffic. That's it for today. Thank you for following this video, and don't hesitate to subscribe to this one to not miss the next video, and comment this one and like this video, and see you in the next one. Bye bye.